Why, hello there, students. Whatever time you are listening to this, I say hello to you. This is the review for your polynomial test. Hopefully it makes sense and your big old head isn't in the way anymore. So, methods of factoring. Right, we've done basically 3 methods anytime we want to factor. The first is, what do all of the terms have in common? So, common factors. We look for that every single time first. Right? First, we look at all the terms and see if they have anything in common that we can pull out to hopefully simplify. Next, we have quadratic style factors. Okay, and I say quadratic style because they also work on 4th degree polynomials, like the g down below there. Okay, we're going to factor that one quadratic style, right? What numbers multiply to give you the top and add to give the middle, right? That quadratic style thought process when we're factoring. And then the last one we have done is factoring by grouping. Okay, factoring by grouping. So those are our 3 methods of factoring, and they kind of lend themselves to specific type of questions. So if we're looking at f of x here, we should notice that each of these terms have an x in common, right? So the first thing we do is we factor out what they have in common. Now they all have an x, but there's a minus in front, so we're going to factor out the minus from all of these also. Okay, we don't really want to do a quadratic style factoring with a negative x squared. So factor the negative out of all of the terms. So all the terms are going to change signs. This one is going to become a positive x squared. This one will be a negative 7x or a minus 7x. And this one will end up being a plus 12. X squared minus 7x plus 12. So here we have, once again, a quadratic that we're going to try and factor, okay, with our quadratic style knowledge. So we're asking ourselves, what numbers multiply to give you 12 and at the same time add to give negative 7? Okay, what numbers multiply to give you 12 and add to give negative 7? And hopefully you recognize those as being a negative 4 and a negative 3. So that is your complete factorization. Okay, we have our common factor of negative x, and then our quadratic leftover factors to x minus 4 and x minus 3. Okay, quadratic style factoring and a common factor. So let's move over to look at g. So this is it has a 4th degree and a squared and a number, so this is also a quadratic style factorization. What numbers multiply to give us negative 20 and add to give negative 1? Okay, that's our thought process when we're factoring something like a quadratic style factorization. And hopefully you know those numbers are negative 5 and positive 4. Right, negative 5 times 4 is negative 20. Negative 5 plus 4 is negative 1. So our x to the 4th is going to factor to x squared minus 5 and x squared plus 4. So the difference here with this quadratic style when we have an x to the 4th is your factors both have x squareds on their terms, right? These are x squareds, not normal x's. So the question is, can you further factor either one of these two things? Okay, and if the 5 were to have been a perfect square like a 9 or a 16 or a 4 or a 1, then yes, we could factor that to x minus and x plus. But we're not going to do it in this case, x squared minus 5. 5 is not a perfect square, so we're just going to leave it like this. Okay, and you can never do it with an x squared plus. That does not factor like you think. Okay, and then our last one, our factoring by grouping. Okay, we group the first 2 terms together, and we group the second 2 terms together. Right? We just group them. And now we ask ourselves, what do these 2 terms have in common? What do x cubed and 4x squared have in common? And we'll write down that they have an x squared in common. Right? They have an x, squared. So we're left with x minus 4 in our parentheses. Right, that's what is left. Now we look at our second terms and we ask ourselves, what do a minus 9 and a 36 have in common? And if there's a minus there, it's a minus that they have in common. So we're going to pull the negative out also, leaving me with a x minus 4 in parentheses. Okay, and the way it's supposed to work is these guys combine to give us one factor of x minus 4, and the other two combine to give us another factor of x squared minus 9. And then we ask ourselves, can we further factor x squared minus 9? And the answer is yes. That factors to x plus 3 and x minus 3, right? Because 9 is a perfect square, so it is a difference of square factorization. And there is it completely factored, right? Nothing can be simplified. We can't go any further, so that's the complete factorization. Okay, and we use this, of course, to find the zeros. We would set each of your factors equal to 0, and we would see where they cross the x-axis. Okay, the next part says, how does the remainder from synthetic division relate to the y value of the function? Okay, so let's look at the problem below and see if we can figure that out. What can be said about the value h of 2 here, and the remainder when it's divided by x minus 2? So we're going to figure out how these things relate. So h of 2 means plug 2 into your equation for x. So I have 2 to the third power minus 4 times 2 squared minus 9 times 2 plus 36. Okay, so I am replacing I'm replacing x in my equation with positive 2. Simplifying that, right, doing all the multiplication and cubing and squaring and combining like terms gives me a y value of 10. Right, so this is the y value when x is 2. So let's look at the remainder over here by synthetic division. Right, we set your factor equal to 0, so we're going to synthetically divide with positive 2. So 1 minus 4 minus 9 and 36. And let's see what we get. So I have a remainder of 10. Oops, that's the wrong one. I have a remainder of 10. So if I look at the remainder and the y value, well, how do they relate? Sure enough, they are equal. And they always will be. So up here, how does the remainder relate to the y value? The remainder equals the y value. Okay, that's the remainder theorem. As long as the number that you're synthetically dividing is the same as the number you are plugging in, those two things should be equal. Now, if they're different numbers, if that was a positive 2 and a negative 2, then they would not be equal, potentially. But if they are the same number, then they have to be equal. Okay, the next one. How do you determine how many times that is a factor of a polynomial? So you want to do synthetic division until you no longer get what? A 0 remainder. We're going to synthetically divide until you no longer get a 0 remainder. Okay, that's how you determine how many times it's a factor. Right? Synthetic division, synthetic division, synthetic division. This was like number 1 on your quiz over polynomials yesterday. The first question asks you, how many times is that a factor? And this says the same thing. How many times is x minus 1 a factor? So we're going to synthetically divide with positive 1. Okay, so 1 minus 1 minus 3, 5 minus 2. So here comes our synthetic division. Check. One time so far, right? So we get a 0 after we do it once. Now let's try it again with the same number 1, but now we're using these 4 terms. Okay, synthetically divide again. Bam, we got another 0. Awesome, synthetically divide again. So I'm going to come over here. I had 1, 1, and minus 2. Using red this time. 1, 1, 2, 2, 0. Bam, it happened again. Now we're going to try it another time with these 2 numbers. 1, 2, 3. Nope, sorry, it didn't work again. So now we count. I have 1 0, 2 zeros, 3 zeros. So how many times is it a factor? It's a factor 3 times. X minus 1 is a factor 3 times, which means it has a multiplicity of 3. And the graph will do what at the x-axis if it has a multiplicity of 3? Good, it flattens. The graph will flatten as it crosses the x-axis. So if you have an odd multiplicity, a multiplicity of 1 or a multiplicity of 3, then the graph crosses the x-axis. And if you have a multiplicity of 2, it does not cross the x-axis, it bounces. Okay, the last question, how do you solve this polynomial greater than or equal to 0? Okay, how do you solve it? What we're looking for is intervals. We're looking for the interval, right, in brackets because it says greater than or equal to. So we're looking for intervals where your graph is above the x-axis, because that's where the y values are positive, above or on your x-axis. Okay, so we'll do this later on the, well, one way to do it is by doing that number line analysis. Okay, doing a number line analysis, which is a pretty good method, okay, to do a number line analysis. First, we have to solve each of these. We get x equals 4, we get x equals negative 1, and we get x equals negative 3. Right? This is a wonderful method, negative 1 and positive 4. So we would pick, right, we will pick a number less than negative 3, maybe negative 4, and we'll put it in for x for all of these things, right, every one of these, and we're going to see if that sign is positive or negative. Okay, so let's see, negative 4 minus 4 squared is a positive number. Negative 4 plus 1 is a negative number. Negative 4 plus 3 is a negative number. Positive times a negative is a positive. So to the left of negative 3, we are positive. That's good to know. That's what we're looking for. Okay, now let's try another number. How about negative 2? Let's plug negative 2 in there. Negative 2 minus 4 squared is a positive number. Minus 2 plus 1 is a negative number. Minus 2 plus 3 is a positive number. Positive times a positive is a negative. So it's negative between negative 3 and negative 1. Okay, so this is our number line analysis. We're pulling in a 0 and we'll plug in a 5, and let's see what we get. So we get positive and positive, which means that our intervals are going to be anything less than negative 3 and everything greater than negative 1. Okay, 4 is included in there because 4 is where it equals 0. So we would write our answer something like this. Okay, from negative infinity to negative 3 with a bracket. And then again from negative 1 to positive infinity. Okay, so we don't have to include, I know that you want to and I've seen you do it, you've included this 4 in here twice before. Negative 1 to negative 4 union Sorry, that's not negative 4, it's a positive 4. Positive 4 to infinity, right? So I've seen this repeated of the number 4. Okay, so if you find yourself doing this with brackets, know that you don't have to do this. This is not the right way to do it. Okay, from negative 1 to infinity encapsulates and includes positive 4 within that graph. Okay, so you don't have to do a separate thing to include positive 4. Okay, now if it were greater than, yes, you would have to use parentheses because at 4 it's 0. So 0 would not be included if it said strictly greater than, but this one says greater than or equal to. Okay, so that's kind of the long way of doing it. So let's think about the shorter way, right? It doesn't say to use a line analysis, so let's do what we know about graphs. We still have our -3, our -1, and our positive 4 intersect. But what is the power? I have a 2 plus 1 plus 1, meaning this is a 4th degree polynomial, right? It's an even polynomial. So we should be expecting your end behavior to go up to infinity on both ends of your graph. And then due to multiplicity, our graph should bounce at positive 4, and it will cross at both of these other places. Right? So it will start up here, and it will end up here, and it will cross at -3, and it will come back up and cross at -1, and then it will bounce at positive 4. So if we're looking for all the places where the graph is above or on the x-axis, right, we have a whole lot of those places. Everything less than -3 and everything between -1 and infinity, right, including positive 4, where the graph is equal to 0. Okay, so the fast way is to do what you know about graphs, right? The long, slow mathematical way is to do a sign analysis, which is a correct way to do it, only sometimes it takes forever. Okay, so when you're asked for that kind of a polynomial inequality problem, if there's an FRQ and it wants you to do it using a sign analysis, then do it that way. But if it doesn't ask you to do one, potentially use what you know about graphing to find those intervals also. Okay, there's the first page. Watch the next video for the second page.